Let me demonstrate ProxiFit, an exercise monitoring system based on proximity magnetic sensing. Smartwatches often use an accelerometer and a gyroscope to track exercises with motion. Butterfly and leg pull down involve substantial wrist motion and thus can be easily detected. However, it is impossible to detect lower body exercises such as seated leg curl from a smartwatch, and sensing exercises from an off-body location is impossible as they do not involve any motion on the device. Dream equipment made of ferrous metal exerts faint magnetism and can be seen as a weak magnet. Therefore, the movement of the equipment can be detected with a magnetometer, which is analogous to a compass. When exercising on leg press machine, the motion of the moving plate causes repetitive magnetic field disturbances. Each of the three plots represents the X, Y, and Z axis of the magnetometer readings from the wrist-worn device, where the repetition is noticeable. Magnetic exercise tracking does not require the motion of the device, thus it can sense lower body exercises from a smartwatch and essentially any exercises from an off-body location. To use ProxiFit on a wearable, gymgoers start tracking as they enter the gym. From then on, exercisers can go through the workout session as usual. The system continuously monitors the absence of motion to detect exercise. Once exercise is detected, the frame normalizer negates any possible posture irregularities. Finally, the sanitized data is fed to the classifier and the repetition counter. After finishing 10 repetitions of leg extension, the user decides to try lying leg curl. ProxiFit does not require any kind of user intervention, so the user can seamlessly transition to the next exercise without interruption. The exerciser steps toward leg press. Note that ProxiFit works well regardless of the weights loaded onto the machine. Motion-based systems can only detect left-arm exercises assuming the watch is worn on the left arm. However, ProxiFit can detect exercise on the other arm as well. Here, the system detects right-arm triceps kickback from the smartwatch worn on the left arm. Pervasive background exercise tracking continues until the user finishes their typical workout routine and stops the system. Signage mode is another mode of ProxiFit which brings in off-body sensing. We expect users to mount smartphones at a comfortable viewing angle so that they can enjoy the large screen interface throughout the exercise tracking. Despite the different sensor location, the concept of magnetic sensing is identical. Therefore, the architecture of signage mode is generally the same as those of wearable mode. The only difference is that one is mounted to an unstable human wrist and the other is done to a firm structure. Thus, the exercise detector is slightly modified to solely depend on the magnetometer. Both the classifier and the repetition counter are shared with wearable mode but with different trained parameters. Note that ProxiFit can coexist with conventional IMU-based systems such as MiLift or even a variant of ProxiFit, MProxiFit, which mimics an inertial measurement unit with a magnetometer. Once combined, ProxiFit can cover exercises both with and without device motion using the device at either on-body or off-body location, delivering holistic coverage of dream weight exercises. In total, 5 lower and 5 upper body machine exercises and 4 free weight exercises throughout 3 gyms are tested. ProxiFit turns out to be robust against aging over 14 months period, moderate spatial displacement, and interference from a neighboring machine as close as 43 cm. Also, analysis over weather and user variables such as temperature, humidity, lightnings, height, weight, and exercise pace revealed no significant impact on accuracy. Thank you for watching, and please refer to the full paper for more information.